In 1952, Harry Markowitz published a paper, which was one of the most powerful academic breakthroughs we've seen in the world of finance. His work changed the way financiers look at their portfolios and formalized an intuition previously suggested by some practitioners. Investors shouldn't put all of their eggs in one basket. Markowitz proved the existence of an efficient set of portfolios that optimize investors' return for the amount of risk they are willing to accept. One of the most important highlights of his work is that investments in multiple securities shouldn't be analyzed separately, but should be considered in a portfolio, and financiers must understand how different securities in a portfolio interact with each other. We already know how to measure the relationship between two securities by calculating their covariance, and that's precisely what Markowitz suggested. Through the combination of securities with low correlation, investors can optimize their returns without assuming additional risk. Markowitz assumes investors are rational and risk-averse, so they are interested in earning higher returns and prefer avoiding additional risk. This leads to the conclusion that, for any level of risk, investors will be interested only in the portfolio with the highest expected return. Let's assume only two companies exist in an economy. Investors can use their shares to form portfolios. We have share A with an expected return of 7%, standard deviation of 5%, and share B with an expected return of 9% and a standard deviation of 8%. The correlation between the two shares is 0.3. A positive relationship means the two securities will likely change in the same direction. At the same time, 0.3 is far from 1, and we can benefit from a diversification effect when we include the two securities in a portfolio. All right, perfect. We know how to calculate the expected return and standard deviation of a portfolio, don't we? Let's do the following exercise. We can calculate the return of 6 portfolios composed of these two stocks. The first portfolio will contain 100% of stock A and 0% of stock B. The second portfolio will contain 80% of stock A and 20% of stock B, while the third portfolio will be made of 60% of stock A and 40% of stock B. The fourth portfolio, 40% of stock A and 60% of stock B. The fifth portfolio, 20% stock A and 80% stock B. And the last portfolio will contain only stock B. Okay, excellent. Let's calculate the expected return and standard deviation of these portfolios. Expected return is easy, isn't it? We only have to multiply the respective portfolio weights by the expected returns of the two securities. And this gives us the expected return of portfolio 1. It is equal to the expected return of security A, given that portfolio 1 is entirely made of security A. Good. I can copy downwards and obtain the expected returns of the other 5 portfolios. The standard deviation of a portfolio is more complicated, but not much. Let's apply the following formula. We have the portfolio weight of security A squared and multiplied by the variance of security A, plus the portfolio weight of security B squared and multiplied by the variance of security B, plus 2 times the correlation coefficient between stocks A and B multiplied by the weights of the two stocks, multiplied by the standard deviations of the two stocks. This is the diversifiable component of the portfolio. The lower the correlation coefficient, the greater the diversification effect that the combination of two stocks will have. To obtain the standard deviation of the portfolio, we'll need a square root of this number. All right, great. We've obtained expected returns and standard deviations of the 6 portfolios. Let's plot these in a 2-axis chart. The horizontal axis will contain the risk of the portfolio, and the vertical axis will show us its expected return. We've obtained the typical shape of a Markowitz efficient frontier. This is precisely what Markowitz suggests. There is a set of efficient portfolios that can provide a higher expected rate of return for the same or even lower risk. This group of portfolios is called the efficient frontier. Its starting point is the minimum variance portfolio, the lowest risk an investor could bear. Points below the efficient frontier represent inefficient portfolios, as for each we can find an alternative portfolio with greater expected return for the same level of standard deviation. Okay, great! We understood the main idea that earned Harry Markowitz a Nobel Prize. In our next lesson, we'll examine a universe with more than 2 stocks. You'll see the calculations we performed here hold true when there are more than 2 stocks investors can choose from. That's it for now. Thanks for watching.